Find the derivative of f of x equals x to the minus 1, which equals 1 over x, from first principles. And here is the graph of f of x equals 1 over x. To compute f dashed of x, we find the limit as h tends to 0 of f of x plus h minus f of x over h. We choose a point P on the graph where f of x equals 1 over x, and we choose a point Q on the graph where f of x plus h equals 1 over x plus h. And so we obtain the limit as h tends to 0 of 1 over x plus h minus 1 over x all over h, which we can rewrite as the limit as h tends to 0 of 1 over h times 1 over x plus h minus 1 over x. And by putting the fractions over a common denominator of x plus h times x, we obtain the limit as h tends to 0 of 1 over h times x minus x plus h over x plus h times x, which simplifies to the limit as h tends to 0 of 1 over h times minus h over x squared plus hx. And we cancel h top and bottom to obtain the limit as h tends to 0 of minus 1 over x squared plus hx. And the expression in the blue box is the gradient of the chord joining P and Q, shown in red. Now we apply a result from the algebra of limits that allows us to rewrite the limit as h tends to 0 of a fraction as the limit of the numerator over the limit of the denominator. And we can note immediately that minus 1 does not vary with h, so the limit as h tends to 0 of minus 1 is minus 1, and we obtain this expression by applying another result from the algebra of limits to the denominator, i.e. the result that we can split the limit of a sum into the sum of limits. And since the limit as h tends to 0 of x squared is x squared, since x squared does not vary with h, we obtain minus 1 over x squared plus the limit as h tends to 0 of hx. If we bear in mind that here x is playing the role of a fixed number, it should be clear that the limit as h tends to 0 of hx is 0, and so the expression reduces to minus 1 over x squared, bearing in mind this fact just mentioned. And so we have that if f of x equals x to the minus 1, which equals 1 over x, then f dashed of x equals minus x to the minus 2, which equals minus 1 over x squared. And here we see a graph of f dashed of x equals minus 1 over x squared. And we note that f dashed of x is negative for all x, which corresponds to the fact that 1 over x is decreasing for all x.